Okay, so just a couple other terms that you may have heard while you're browsing your home internet, or particularly your work internet maybe. So the first is this thing called a firewall. So does anyone happen to know what a firewall is, or because they've been frustrated by a firewall perhaps? Yeah, so it blocks connections. So what a firewall does is it says, all right, according to this set of rules, when a request comes in to a computer, I can either let it go through or I can block it. So that means that the person who set up your network, who you might hate as a result of this, could say something like, whenever a request comes in from facebook.com, just block it. Whenever a request comes in from this IP address, you can just block it. And so I remember back when Facebook first came out, I happened to be on a network where they only blocked facebook.com. So what you could do is you could actually type in something like hs.facebook.com for high school, or harvard.facebook.com, and it would go through the firewall because they had only blocked facebook.com. So other firewalls are susceptible to, rather than typing facebook.com, if I type the IP address of facebook.com, we're OK, because the network administrator only blocked facebook.com, not the IP address. So that's basically what a firewall is. It's kind of this layer that is between you and the internet. So when I say you now, we're talking about the router, because you're just connected to the router. And so the firewall is standing between the router and the rest of the internet, and it basically comes in, every request that comes in, the firewall is going to examine it. It's going to say, OK, are the contents of this request OK? Is where it's coming from OK? And if it is, I'm going to let it through. If not, I'm going to block it. So in addition to just preventing you from procrastinating at work, this could actually be a nice security thing in case someone did something like was accidentally running a web server on their computer or other security holes like that. If one person has a security hole in their computer, then someone could come in and kind of compromise the entire network. And so that's no good. And so this is kind of an additional layer of security that kind of prevents one person from kind of doing something that we don't want the entire network to do. So it's kind of a network level defense. So this is kind of what a firewall looks like. If that WAN is kind of the wide area network that represents the rest of the internet, then there's a firewall between where I'm connected, my local area network. And so there's kind of a router inside of that brick wall. So you may have also heard this term VPN, which stands for Virtual Private Network. And all a VPN does is it basically allows you to access a LAN without being connected to it. So the idea is that when you're connected to a LAN, and that could be a private network, which means that it's not accessible to anyone else on the internet, you can basically put some maybe secret documents there that you don't want anyone else to see. But then if you want to work from home and you kind of need one of those secret documents, there's no way of getting onto the LAN, and so without actually being physically connected to it. And so this VPN thing basically allows you to connect to a LAN securely. So all of your information is encrypted, which means nobody can read it. And so all this does is it allows you to connect to the LAN and kind of pretend like you're on that network, even if you're actually going through a publicly and insecure network. And so that's all we mean when you hear the term VPN. OK, so far we've only seen these IP addresses, and things like CNN.com have just been kind of tangential. So what is CNN.com? So this is something called a domain. And a domain really is basically an alias for an IP address. Right? When we wanted to get our daily news, we don't want to have to go to our address bar and type in like 157.26, dot whatever. We want to somehow type in something that's easy to remember, easy to type, and that's not a series of 4 digits. So domains are simply a way of kind of abstracting away this concept of an IP address. So when you connect to something, you don't care what IP address it is. You only care about this nice human-readable identifier for it. And so this system that allows us to map these things called domains to these IP addresses is called DNS, or Domain Name System. And basically, all DNS does is a way of for us to say, if my browser is going to CNN.com, my browser needs to know what IP address CNN.com corresponds to. So all DNS is this way of going from a domain to an IP address. So typically, when I go to CNN.com, the first thing that I'm going to do is figure out what IP address CNN.com is. Because I can't simply make a request to CNN.com. As we saw, I make requests to IP addresses, because IP addresses is what identifies computers on a network. So with DNS, I can kind of translate from this nice thing I can remember to this actually unique identifier for a computer on a network or on the internet. And it was basically like this big phone book of things. So when the internet first started out, this phone book of domain names was in this one file called hosts.txt, or .text. And basically, whenever someone connected to the internet, they had to copy this file called host.txt and put it on their machine. And so that meant that whatever was defined in this side of this text file, that were basically all of the domains that existed on the internet. So that doesn't really scale anymore, right? Because we'll have tens of millions of copies of this host.txt kind of floating around on the internet. But it does still exist on your computer. So if I'm on a Mac, this file happens to be located in a folder called etc, so /etc, and the file is just called hosts. So if I open it up, after typing in my password, if I open it up, my host file looks something like this. And so what I've done here is I've actually put a new entry. So what I'm saying is bing.com, actually, I want you to map to this IP address. So if this were kind of the beginning days of the internet, that host.txt file that was distributed, it looked just like this. And there was a row for every domain. And so in this row, we're saying bing.com is this IP address. So that means that when I open up my laptop here and I go to bing.com, if this is the only source of DNS, it's going to go through this file line by line and look for bing.com. And it's going to find it. It's going to say, OK, bing.com is that IP address. So now, if I open up a new browser, and I promise there are no tricks here, and I go to bing.com, I actually just went to Google. Because I typed in this etc hosts file, this host.txt, I told my computer that bing.com was actually an IP address that belongs to Google. And so this is how, in the early internet, how the domain names were actually resolved. We looked in this single phone book, and we said, OK, if I just see a string, bing.com, this just random sequence of characters, I just need to know what IP address that is. So because inside of my host.txt file, I said, Bing, whenever you see bing.com, that means you're at the IP address 74. Whatever. So when I make a request to bing.com with this thing defined, that means that my web browser is going to go to this IP address, which is Google. So if I actually get rid of that line, so I got rid of that line, and I'll just clear my browser cache. Now if I go back to bing.com, all is right in the world again. The reason being is I just removed that line. I told my computer, never mind, bing.com is no longer the IP address 74. Whatever. And so now it's going to use the DNS system that we're about to take a look at. So the DNS system is basically, rather than storing all of the domain names and IP addresses that correspond them in this one big file that we kind of distribute everywhere, we're going to make this big, huge distributed database of domain names. So there's not going to be one file, but there's going to be a bunch of different servers all around the world responsible for keeping track of where the domain names are mapped to. So what IP address corresponds to each of these domain names. So each of these machines is going to be called a DNS server. And a DNS server is basically just going to maintain some subset or some list, not every domain in the internet, but some list of some domains on the internet, and record what IP address they actually correspond to. So there are a few different types of DNS servers. So the first that we're going to look at is this thing called a root DNS server. And the root DNS servers are kind of the authoritative source of information. So the root we have to start somewhere, right? So the root DNS server is kind of going to be where we start. So this is where all of the information is originally stored. And what's stored in each of these DNS servers is not kind of a list of a bunch of domains, but actually a list of other servers that have the domains. So right now there are 13 different groups of DNS servers around the world. So there aren't, as literature may suggest, there are not just 13 root DNS servers. If you go to rootservers.org, these are basically where all of the different root servers are located. So there are 13 groups of root DNS servers, but as you can see, they're kind of scattered all around the world. And the reason that we have so many of them is, one, because if something were ever compromised with one DNS server, someone kind of erased a root DNS server, for example, and we didn't this is kind of the original source of information. If we delete it, we suddenly don't know where all of these domains point to. So we have to have many for that reason, and also because we don't want tens of millions of people connecting to the same server at once, right? Because that single root DNS server would get overloaded. And it's just totally not realistic to have 13 servers powering the entire world. So instead, we have all of these different root DNS servers that you can connect to. And each of these servers stores some information about domain names. So as I said, it doesn't actually store these mappings from domain names to IP addresses. Instead, they're going to store mappings between domain names and some other servers. And those other servers are called TLD DNS servers. And these TLD DNS servers basically take charge of a certain TLD. So TLD stands for top level domain. And when you go to something like cnn.com or cse1.net, that .com or .net is what's called a TLD. So any domain on the internet has to end in one of these valid TLDs. So we can basically split up where all of the information is stored based on these TLDs. So I have this server over here handles all the .coms, this server over here handles all the .nets. So the root DNS server stores locations to these things. So these things, unfortunately, don't store the answer either, but they store the location of a server that actually does this time. So these servers are called the authoritative name servers, and these things are basically managed by companies like GoDaddy or other hosting places that can allow you to actually host a website or buy a domain. And these are what you actually interact with when you, for example, buy a domain. So let's take a look at an example of resolving a DNS request. So we typed in cnn.com into our web browser. We just saw there are all these different types of DNS servers that somehow interact. So let's see what actually happens. So as we saw before, I typed in bing.com. So the first thing my browser did was it looked inside of this hosts.txt file. And if that hosts.txt file gave me an answer, then we're done. So the first time I did it, that file did give me an answer. It said bing.com 74.something, we're done. But we saw that file, it didn't really have anything else. So for every other request I make, that file is not going to give me an answer. So the next thing I'm going to do is I'm going to start asking DNS servers now. Because my computer doesn't know where it is, so I need to figure it out. So the first thing I'm going to ask is a question to this cache DNS server. And these things happen to be managed by your ISPs. And so if you have a bunch of people connected to Comcast, and they're all asking for Facebook.com, it'd be really nice if we can just give them an immediate answer for Facebook.com. We don't have to worry about these root servers or TLD DNS servers, whatever. So these cache DNS servers are just these things maintained by Comcast that say, OK, well, if we had a bunch of requests for Facebook, we're just going to temporarily remember where Facebook.com is, so we can just give people answers faster. So much like in lecture 2, when we talked about the L1 cache and the L2 cache, it's just kind of a place to store temporary information that we need to access again and again and again. This is exactly what these cache DNS servers are. We're getting requests for the same thing over and over and over again, so let's just remember the answer temporarily. So again, these things aren't necessary for your DNS to function. So if the cache DNS server doesn't have my answer either, that's when I need to start going through each of these different servers. So the first thing I'm going to do is I'm going to ask a root DNS server, hey, I need the IP address for this domain. The root DNS server is going to say, OK, great, you're looking for cnn.com. I'm going to point you in the direction of the correct TLD server. And again, there aren't just one TLD server for all the .coms, all the .nets. There are a bunch of these things. And that's why we kind of need the root DNS server to tell us which one to go to. Right? We're going to basically connect to whatever root DNS server our ISP tells us to. And that could be based on things like, we don't want to send 100 people to this one, then 100 people to this one. We kind of want to distribute, kind of like the parallelism we talked about. So we basically connect to one of these root DNS servers. And then the root DNS server is going to send us to one of these TLD DNS servers. TLD DNS server is going to say, OK, you're looking for cnn.com. I know who knows that answer. It's going to be the authoritative name server who's going to respond back, yep, cnn.com is 157.226.something.something. And so then the answer is going to kind of propagate back to my web browser. So the authoritative name server is going to tell the TLD server, is going to tell the root server, it's going to tell the cache server, maybe, which is going to tell me. So basically, through this hierarchical process, that is how we go from a domain to an IP address. And so there's actually a really cool website that actually traces this process for you. So for example, I just typed into this little text box here, I want to trace how I figured out what IP address cnn.com corresponds to. So I click trace, and I'm going to get this. So what happened is, here are the IP addresses of all of these root servers. So my request first went to a root server, just because this site isn't bothering with host files or cache servers or anything. So we go directly to a root server. And the root server says, OK, I connected to this one, which has this IP address, and so I'm going to get a response. I said, OK, I'm looking for CNN.com, so I'm going to send you to a TLD server corresponding to .com. So here we go. We have all of these TLD servers now. And the TLD server is going to send me to this. So we said before that name servers are probably managed by the company that you're using to host your website, so where the actual server that your website is sitting on. So that means that Time Warner, for example, means that CNN is using somehow Time Warner, and they know where the actual IP address to CNN.com is. So that's how I kind of went through this hierarchy. The root server sent me to the TLD server, sent me to Time Warner, who sent me an actual answer. Yeah?
So it looks like there's a series of, I don't know if options is the right word, but for each step of the way, so how is that choice made?
Yeah, so how is that choice made each step of the way? So as you said, it's probably based on some mechanism that doesn't overload any single one. So for example, if we just choose one randomly, that would mean that, OK, well, that means that there aren't too many on A, because it's an equal chance of going on A than it is getting on B. Right? If we just flip a coin to go from A or B, then half the time we're going to go to A, half the time we'll go to B. So there could be more sophisticated things going on under the hood. But the basic idea is that we don't want to overload any single one of these, or else it's just going to slow down. And so that's how these decisions are made. Probably some degree of randomness, or at least keeping track of where things have been going. OK, so that's how we look up a domain name. So sometimes we will type in a domain name that doesn't actually correspond to an IP address. For example, in this example, someone typed in something.orgz. And .orgz is not a valid TLD, which means that this domain is not valid at all. So if I, on the Harvard network, type that in, so something.comz, it's going to Google it for me. There we go. So I get a page that looks like this. It says Google Chrome could not find this, and it gives me a nice suggestion. So on the other hand, if maybe you're using Comcast or another ISP, you'll get something instead that looks like this. So Google Chrome actually thinks it found this page, because it got some response, and now it's displaying it. So why would Comcast want to do this? I'll give you a hint. What does that? Yeah, so these are now ads at the top. So you made a typo in your address bar. And now that means Comcast seizes this opportunity to send you advertisements. So that means that these people here paid either Google or Yahoo or Comcast or somebody to have the privilege of being displayed in your web browser when you make a typo in the address bar. So really, this isn't really that great, right? I mean, we want to know whether or not we made a successful connection or not. Here, we're trying to access something that doesn't exist at all. And yet, here we go. We get this perfectly valid web page that we can interact with. And so some people would say that Comcast shouldn't really be doing things like this, where other people might not be so upset. And so this gives rise to this larger debate, which we can talk about at the very end, called net neutrality. But the basic idea behind net neutrality is it's talking about what degree an ISP can exert over your internet connection. So for example, right now, when you buy a Comcast plan, you just buy a plan and you connect to the internet. That's it. Anything on the internet you're allowed to connect to. So what could exist is something like this. So rather than paying a flat fee to connect to the entire internet, what if you instead paid maybe a lower fee, and then if you wanted to access news, well, that's an extra $5 a month. If you want to access sports, that's another $5 a month. And so this is something that comes into the debate of net neutrality. The question is, should something like this be allowed? Right? Do ISPs have the authority and have the right to kind of tell you what parts of the internet you can and you cannot access? So you're kind of, maybe you're paying a lower price because, what if I don't care about Netflix and Hulu because, I don't have those services? So I might end up paying less. But then there's the larger question of, well, do ISPs really have the right to do this? Right? Because then suddenly, your internet connection is now kind of under the jurisdiction of Comcast. And if they decide that this site here is worth $10 a month and your site's only worth $1 a month, then suddenly that's going to make it influence whether or not you use Google or Bing. maybe. Yeah?
That means basically that the lower price you pay, Comcast will say they want you, of course, to pay a higher price, but the lower price you pay, the more ads.
Yeah, so there's another good example. So for example, what if you paid a lower price but got ads? And so that's also something that could relate to net neutrality. Exactly. So this is totally fictional. This is just someone that on Reddit made up. So this is totally fictional. And another model could be, well, what if Comcast decides that somehow you get advertisements no matter where you go on the internet? Comcast will send you advertisements for a lower price. So this is another one of these larger issues of net neutrality. You know, some people think, yeah, whatever, they're just advertisements. And other people say, no, this is my freedom to access the internet. You can't do that to me. So actually, we can have a discussion about this afterwards if we still have time. Because this is actually a really interesting question. And right now, there are a lot of bills that have been floating around the House of Rep and the Senate recently that relate to exactly this issue. So when you hear net neutrality, maybe on CNN and Wolf Blitzer's going on and on about it, this is what we mean. Just can your ISP kind of dictate which parts of the internet you can and can't access? And different people, whether you're an internet user or you own a business on the internet, might have very different opinions about whether or not this should be the case.